Hello all and welcome back. So in this video, let us now move forward and now let's write the code for the solution which we discussed in our previous video, which is constructing a tree from pre-order and in order. Now I'm pretty sure based on our discussion in the last video, you must have given the same a try. So if you are able to do so, that's a very good sign because again, it's not a very easy question to master. It actually requires a lot in-depth knowledge of many tree concepts. So now let us see how are we going to approach the solution. So in the last video, we actually have a full discussion on how we will be reaching out for the solution. So let us now use the same. Okay. Yeah. So this was the proper discussion which we had. Now let's go to VS Code and try to write the code for this particular problem. So def construct tree from in order and pre-order. Great. So this is my function, everyone. Now in this, I will be getting a in order and a pre-order. Okay, so I think it was in this way only we took here as well. Yeah, in order and pre-order, and I will be getting these four values. Now, if you are making, if you are let's say getting in a problem on any website or somewhere, you are getting just the in order and pre-order. Then there are two things you can do. The first is you can create a helper function where you are sending the length. So start will be 0 and that will be n minus 1 end. Or you can actually slice it as well based on our discussion. I honestly will suggest that it's better if you do it the way we have discussed because in that we are not creating any extra memory. We are just using the in order and pre-order along with indexes, something which we have seen in our recursion discussion as well, that how overall using it that way is helpful. Okay, great. So cool everyone, let us now start. I am for this assuming that I am getting these things here: in order end, pre-order start, pre-order end. So we will be sending out these things. We will see if it is required, then we will of course create a helper function if we try to solve it somewhere else. Great. So now the very first is the base condition, something. So if my in order start is greater than in order end, or pre-order start greater than pre-order end, then we know of course that nothing is possible, right? So it's in a way say that we don't have a pre-order or in order for my tree. So I can just return none. That's exactly a way of saying when you will be sending me an empty in order or pre-order. Okay, when start will be 0 and end will be minus 1. So that's why this base condition is a lot required. Great. Now, let's first get the root data. Okay. So, in this example, I think this is the proper analysis which we need for solving this particular question. Root data I know is kept in starting of my root. Okay. So, sorting of my pre-order. So, what can I write? Pre-order. Should I write 0 here? Pre-order 0 starting. Well, that's one mistake to avoid. Because see again we are using recursion. Okay, so 0 will work for the very first root, but when you will call for the recursive on left and right subtree, then this is not what we will be doing. Again, the discussion of this has been done in our recursion a lot much in depth to avoid using 0. Instead, what we should use? Pre-order and pre-order start. Okay, so this is what we should use: pre-order start. This is where my root will be kept. Once I have the root, then all I have to do is create a node for my root. So, okay, I think from predefined binary t. So here we have this all the examples, and we have binary tree node, predefined function, and I've also added this print level wise here only. So if you remember, we have this commons file in previous modules, right? So here I have added this function, that binary tree node, and this print level wise in this file so that we can use it as our commons. Okay, great. So I have all these three functions now, everyone, which we have written. Now I can create a binary tree node with this data. Great. So I have this particular node now. In our example, if I just talk in terms of our example, this is what we took, right, everyone? So now I have created this one node. For this subtree and for this subtree, I just have to call on my call recursion on the left and right part. So how will that be? Root dot left equals construct in order, preorder. Then what we can say, left in order start, left in order end, right in order start. Sorry, left preorder start, left preorder end. Okay, so this is what I have to send. Let me zoom out. This is four values which I have to send for my left subtree. Similarly, what I can say, root dot right is construct from in order and preorder, in order, preorder, right? For the right subtree, we just have to say right in order start, right in order end, and right preorder start, right preorder end. So now all I have to do is to just get these 8 values correctly based on our discussion, and we will be all good. Great. So let us write these values down, everyone. Left in order start, left in order end, left preorder start, left preorder end. Okay, great. Similarly, right in order start, right in order end, right pre-order start, and right pre-order end. So once I have these 8 values, then I can very comfortably just call recursion. Okay, great. So now let us see, based on our analysis, left in order start. I know it's going to start from here, from where my in order starts. Okay, everyone. So I hope this is clear to each and every one of you. Nothing we are doing here, something which we have discussed already. So if you have not seen the last video, please make sure that you see that. It is a lot important. So this value I have with me, this I can directly write in order start. This is the value. Great. Now let's see for the next value which we have. Now left in order ends. It's going to be in order root index. Okay, so I will have to find the index of my root. If you all remember, I have to find the index of my root. So let us find that, everyone. Let's say root index in order. Root index in order. Let me take it -1 for the time being. Now I have to run a loop for I in range. Okay, so I will have to run this loop for I in range. In order start to in order end +1. Okay, so I hope now each and every one of you are able to understand this as well. What I have done here. I have just written a loop, but I have to make sure that this loop, it starts from where my in order starts. So just to give you an example, just like recursion, we have to think on this part, on this particular part, which is in order start and in order end. So I have to find my particular overall root in this portion. Okay, not the whole array, not the whole list or array. So great, everyone. Once we find it, let me just do one thing quickly. Once we have this, for I in range, in order start, in order index +1, if we have in order of I equals to my root data. If this is the case, then I can say my root index equals I, and I can break from the loop. Okay, great. If due to some reason we have written or we have done some mistake, if it is still -1, Okay, then we should return saying we should either raise an error or we should say print here, print root not found in order. Please check logic. Okay, so this is something which we have to print everyone, and we should return none so that we can check for our error if we have made anywhere. Great. So once we have done this thing, once we have done this particular thing, and again, you can do this particular thing with the help of index function as well. So another way of doing this is like this: in order dot index. Okay, this is a list. So I will be getting a function index where I can say what I want to find and how basically I want to, from where to start and where to end. So the function I'm saying is something like this. Just that you should be aware of these, but I will still say always to follow the basic principle. So value, start and stop. Okay. Reason I want all of you to follow this way is that in languages, in other languages, like let's say C++ or Java, maybe this index function is not present. So it's better if we are using the way it is common across all languages, because we don't have to master a language, we have to master a concept. Great. Now, once I have this, I know root index in order minus 1. This is my end. Root index in order minus 1. Then let's talk about left pre-order start. Left pre-order start. I know that it is pre-order start plus 1. Pre-order start plus 1. So it's going to be pre-order start plus 1. Okay, so this is the index from which it starts. It will not be just single one. So here you might say that this index is 1. No, it is not 0 plus 1. Again, I have to do for pre-order start plus 1 because I'm talking about some portion in my list. And that is the most complex part of this whole question. But once we master this, then future questions can be easily done with this. Great. So let me remove this. Yeah. To find out this particular thing, we wrote an equation which was something like this. So left pre-order end. This is what we need to find. Left pre-order end. It is left in order end minus left in order start plus left pre-order start. So left in order end minus left in order start plus left pre-order start. So this will give me the end index. So we have done the 4 values. Now let us talk to the and jump to the right subtree part. Okay, everyone. So I hope each and every one of you are able to understand these 4 values. Again, might be a little complex. It will take you time. Like, see, this is not a question which you can do, say, in 10 minutes if you are doing it for the first time. It should take an hour because that hour is going to help you in making sure that future question you can do in 10 or 15 minutes. So this whole analysis, it's again a lot important. Okay, great everyone. So now let us see exactly what we have to do. We have the right in order end and right pre-order end very easily available to us. So let us write them. This is going to be in order end and this is going to be pre-order end. Okay, great. Now let us see exactly what pre-order start is. We know that if I have left pre-order end, which I have with me, I can just directly add plus 1 to this. Okay, why? Because where my pre-order of left ends, which is here, I can just move to 3. Something which we have discussed a lot in depth in the last video. So it's going to be left pre-order end plus 1. Okay, everyone. So I hope this is clear as well. No one should have any doubt in this particular thing. Finally, we are left with right in order start. So let me add it here. Right pre-order start. Reason in the end is because I want to use these things. Again, we can use this equation. We can use this equation. Right pre-order end minus right pre-order start is this. Okay. So I will write this equation down here so that each and every one of you remember this. Right pre-order end minus right pre-order start is equals to right in order end minus right in order start. The reason this works is that again, it is just length which I'm calculating, and I can be sure that length is going to be equal for sure. So to get this particular thing, okay, what I have to do, I think I just need to write right in order end minus, I can add a bracket here. This will become positive. Okay. So write pre-order start minus, this will become negative. Right? Pre-order end. And yes, I think we should be done with this particular analysis. So let us try to run this everyone once. Okay, everyone. So let us try this out. One thing more. So for this particular thing, we have calculated it using this formula, right? Where we took this to this end and here. One thing we missed out actually, if we see, I can directly say that if I have this particular in order root index, plus one is where my right subtree is going to start. Okay, for in order. So I think that's a better way of taking this. What I'm saying is, I can just say root index plus one. This is going to give me from where my root in order starts. Okay, so it is starting, this in order is starting from here. It is in order root index plus one directly. Okay, so let me just update it here as well. Root in order root index in order root index plus one. Okay, so that we know that where we have to use these exactly. Great. So cool, everyone. Now let us try to run this once and see if we have done any other error. Once, it's always a good strategy again to just see your code before submitting once. Have a quick look. So we are checking this as a base condition. Maybe I can write this as well. Base condition. Root data I'm using as pre-order start. Then root, I'm getting binary tree node root. It should be root data. Great. Now root index in order minus one. Okay. We should remove this. This we just wrote for explaining. For I in range this, I am getting the root index in order which is equals to I. Great. That is fine. If root index in order minus one, then we have to show the error. Then I'm calculating this value. So left in order start, left in order end, root index minus one, left pre-order start plus one, pre-order end, I have to calculate using this particular value. So pre-order start plus, maybe I can just copy this and make it in the start so that it is like this. The reason for this is we can actually take this as the length. So this whole we can take as a length. So we just have to add the length to wherever my start is. Wherever my this start is, I have to just add the length to get to the end. Okay, great. Now root it in order end is equals to in order end. Root pre-order start is equals to left pre-order end plus one. Left pre-order end, it is here plus one, that is fine. Then we have right pre-order end. Sorry, I read it as root. It is right pre-order end. It's pre-order end. That is fine as well. And right in order start, we can easily get using this. So seems like this will work. Let us just quickly check it everyone's. So let us take this way I've written, right? So pre-order is something like this. In order is this. In order is this. Great. So just have this quickly. And then I have to call it here. So just let us get n as well. N is equals to length of in order minus 1. And I can get my root from here where I'm sending in order, reorder 0 n minus 1, 0 n minus 1. Okay, so this is how we can write it, everyone. And once I get my root, I can just print level wise the root. And let us now try to run this whole. Okay, so glad that it worked in the first try. Let us see if the answer is right. Let us try to construct this, everyone. Will be good if we are able to get it right in the first try. 1 is there, left is 2, right is 3. Then we have 2, left is 4, right is 5. Okay. Then for 3, it is saying none, 4, none, 5, none. Okay, so seems like we have missed out on this particular 6. Okay, let's see where we have made the error, everyone. Just quickly check where we have made this error. Values all seems to be right here. Uh, Let us see where we have missed it out. If we are missing on the last node, means like we have not sent it somewhere or our indexes are wrong. Okay. So this seems to be right. We have checked this as well. Okay. So this is pre-order. This is in order. I'm calculating n, which is length. Okay. So we have made a mistake here, everyone. If you will notice, it should be length is n and I'm passing this n minus 1 like this. Okay. So the mistake we did was I'm calculating n as n minus 1 and then I'm removing the last element. So this 6 gets removed due to this particular problem. Okay. Great. So yeah, 6 was getting removed. Just that tree was getting sent. Let us now see this, everyone. So if I run this now, after correcting this, this seems to work. Is it? Let us try to quickly work then. So we have 1, left 2, right 3. Then we have 4 and we have 5. And now 3 we have 6. So yes, everyone, this seems to actually make our tree fine. Now let us try one thing as well. This code, is it actually working well for all the cases? So for that, this is actually a same question which is there on the lead code. Okay, question 105. Construct binary tree from pre-order and in-order. So the overall logic and everything is same. There is 2 million submission, which is pretty nice. And you can see that 1.3 are accepted. So around 55-60 submission rate. Should be fine. Let us do one thing. What we have to do, let us copy our code. Okay. Let us copy our whole code. Let us paste it here and see what exactly will we be needing to change. 1 second. Great. So let us see this, everyone. What exactly do we need to change or call? Return this particular, and so we are sending pre-order first. It is sending, we are taking in order first. It is sending pre-order first. So in order, pre-order, length of in order. No, first 0 will be there. So 0, length of in order -1, 0, length of pre-order -1. It's going to be the same, but still. Yes. So we will be returning root, which we are returning back. And one thing more we have to always check in these questions. It is saying that it's a tree node and we are saying that it's a binary tree node. So always just check for this thing as well. Okay, everyone. And yeah, I think all the other things are fine. We have now just transformed this problem into our use case. And this is what I was saying when I meant by helper function. Okay. So let us run this. Okay. It is giving an error of unmatched. One error. Okay, one extra bracket is there. Should be fine. And yes, I think it seems to pass. Let us submit. Great all. So yeah, it seems we are able to do the solution, beating lots of them. Should be fine. Small optimization should can be done, of course. But overall, this code seems to be working for each and every test case now. Okay. So yeah, that's a great thing overall. I think all of you must have understood this. Please make sure that you try to code this once at your ends. Again, question after the discussion is a lot easy, and it is a question which will take 30 to 45 minutes minimum. Okay. So great, everyone. I hope this is a lot clear. Again, we have understood this with so much depth. Just try to revise this whole sheet once. Okay. And I'm pretty sure that you will not be making a mistake in this particular question. Okay. So let's meet in the next video, everyone. Please do try and write this code once at your end as well. Thank you.